In this video, I will cover the topic Laplace transform. What is this Laplace transform? Laplace transform is a mathematical tool which converts time domain signals into S domain. S domain is nothing but frequency domain, which is S is equal to sigma plus j omega. Sigma is the real part and j omega, this is the imaginary part. It converts time domain signals into frequency domain signals. Now let us consider the basic applications. Why we use the Laplace transform? Laplace transform is used in order to find the integrals like integral 0 to t x of t into some t into some e power t. X of t may be sin t, cos t, whatever it may be. This function may be, let it be sin t. This type of integrals can be easily solved by using a tool called Laplace transform. And also by using the Laplace transform, we can able to find transfer function of a system. By using the Laplace transform, we can able to know the stability. And also by using a tool Laplace transform, we can solve the problems related to differential equation. Problems can also be solved by using a tool called Laplace transform. Now these are the applications of Laplace transform. Now let us observe synthesis and analysis equation. X of t whose Laplace transform is x of s. Laplace transform of x of t, which is equal to x of s, which is equal to integral of minus infinity to infinity x of t into e power minus st dt. This is called bilateral Laplace transform. Bilateral Laplace transform, LT. So Laplace transform, let us denote with LT. If I write in between 0 to infinity, x of t into e power minus st dt. This is called unilateral Laplace transform. Minus infinity to infinity is bilateral, 0 to infinity is unilateral. If I send L towards this side, that becomes Laplace inverse. Now let us observe x of t, which is equal to Laplace inverse of x of s, which is given as 1 by 2 pi j integral of sigma minus j infinity to sigma plus j infinity x of s into e power st ds. This is the inverse Laplace transform formula. Inverse Laplace transform formula. And this is the Laplace transform formula. Laplace transform formula. This Laplace transform is introduced by a scientist called Laplacian. Now let us have Laplace transform for some standard signals. So let us have Laplace transform for standard signals. Okay, let us observe here. The first one is Laplace transform of 1 is equal to 1 by s. And second one, Laplace transform of k constant which is equal to k by s. Laplace transform of t is how much? 1 by s square. Laplace transform of t square, which is 2 by s cube. Laplace transform of t square by 2, which is 1 by s cube. Laplace transform of e power at, 1 by s minus a. Laplace transform of e power minus at, 1 by s plus a. Laplace transform of sin at, which is equal to a by s square plus a square. Laplace transform of sin h at, which is equal to a by s square minus a square. Laplace transform of cos at, s by s square plus a square. Laplace transform of cos h at, is equal to s by s square minus a square. Now, Laplace transform of t power n is n factorial by s power n plus 1 if n is integer. If n is fraction, gamma of n plus 1 by s power n plus 1. If n is fraction. Now what are these gamma functions? Gamma 1 is 1. Gamma of 1 by 2 is root pi. The value of gamma n is n minus 1 factorial if n is positive integer. If n is negative integer or 0. Gamma of n is not defined. It is not defined. If n is positive fraction, gamma of n is n minus 1 gamma of n minus 1. If n is negative fraction, gamma of n is gamma of n plus 1 by n. So these are the very important formulas regarding gamma of n. So these are the Laplace transform for few standard signals.